Hello everyone, my name is Abhishek Ranjan. I have been working with MySQL Runtime team for last 3 years and 9 months. I am here to present on the topic metadata storage in MySQL systems. This is the safe harbor statement, which basically says whatever I am presenting here today is for informational purpose and should not be used to take any business decisions. So this is our program agenda for today. First we will see what is data dictionary, then we will move to the traditional way of storing metadata in the MySQL. Then we will move to what is new data dictionary, how we are using it and what are its benefits. So what is data dictionary? Most of us are familiar with the definition of metadata, which basically says metadata is the information about the other data. So what does this mean in case of databases? In case of databases, the metadata refers to the structure of the table and column definitions, index definitions, relations between the tables, what are the constants on the table, foreign key definitions, what is defined inside the stored programs, etc. So, and data dictionary is basically metadata repository. So, data dictionary contains the meaning of metadata, where to store a metadata, how to fetch, whenever user or the server requests any metadata, how to fetch it, from where to fetch it, what is their relation, what is their origin, who has the access to it. So this is the basic diagram of our overview. So whenever we create a table or stored procedure or any database object, the data dictionary basically stores all the metadata for the database object. Now the question comes, where does the data dictionary fit into the server architecture? So this is a client-server model in which here is the client and this is the server executor part and here is the data dictionary. So data dictionary exacts with the three components. First one is the executor, second one is the information schema and third one is the storage engine. So in the executor, the data dictionary lies after the parser. While we are parsing the query, we don't want to know if the table structure is correct, if any constant are being violated. We are only concerned about the syntax of the query. If the syntax of the query is correct, the parser lets the query go forward, and after that, the data dictionary comes into picture. The metadata of the table or any other database object is fetched and validated. The information schema stores or shows the metadata whenever requested by user, and it directly queries the data dictionary to fetch the data. InnoDB and other storage engines may use data dictionary to store any specific data only used by storage engine. So let's see how MySQL traditionally stores metadata till now. Whenever you issue a create table statement, the MySQL creates a binary file with a table name and extension .frm. This is called .frm files in MySQL systems. This stores the metadata for the table. For triggers, we have .trg and .trn files and so on. So there is one file-based system. Then we have some system tables like MySQL.timezone, MySQL.from, MySQL.users. All those are tables inside MySQL database to store the metadata, and InnoDB has separate data structure to store the data dictionary informations. So the traditionally MySQL is a combination of InnoDB internal data dictionary, system tables and file-based systems. And this is represented here as the data dictionary in the center. It is the system of all the file systems, system tables and internal data dictionary. When the information schema queries on the data dictionary, it has to do either file scan, table scan or internal access to the data dictionary to fetch the metadata, and the storage engines communicate through the data dictionary. This is not the most popular way to store the data dictionary. So the other databases mostly use relational tables to store the metadata. So what was the problem in this system? Why the MySQL is going to new data dictionary? So the first point, information schema performance. For this we have to see how information schema works. So information schema, whenever you file a query on the information schema, it goes to every FRM file and every table in the MySQL system and reads it and fetches the data to create the rows. So for every query it has to do the file scan again and again. So this causes the poor performance in information schema. Further, because we are handling files, we are not cache safe. So if you are running a DDL and the server crashes in between, you will not know what has happened to your metadata. The server might read it again, or the server will not recognize your table again. Now the third problem is inconsistencies between files and tables. So this basically refers to what we are following in relational database is the SQL standards. We fire SQL queries and follow the rules defined by SQL standards. But internally, if you are using file system, then we have to obey the rule of the file systems of the operating system. So whatever the SQL may allow, the operating system may not allow. So this leads to a very problematic scenarios in handling some of the use cases. And as I told, there is a separate data dictionary for InnoDB. InnoDB maintains its internal data dictionary. So basically, there are two places where the data dictionary tables are stored or metadata is stored. So if there is an inconsistency between the two, then you might lose your data. Similarly, there are different operating systems have different file systems. Like Windows file system is case insensitive. The table names, this leads to extra complexity when handling those operating systems. When the server cannot guarantee crash safe DDL, then the problem continues to the replication. The replication might break when the server cannot guarantee a transactional or crash safe DDL. Now even our DDL is not even atomic at this point and too difficult to extend. That means if we add any new feature in the server, then it is difficult to extend it to the metadata storage. So we will move to what is new data dictionary. So whatever the information we are storing in the files, flat files, system tables, InnoDB internal data dictionary will be now stored inside InnoDB tables. These are relational InnoDB tables. So InnoDB provides the feature of crash safe and reliability. This will be the single repository of metadata. So for MySQL server, storage engines and for plugins, all the metadata will be stored in the one data dictionary. There is redundancy. So if your server ever crashes, you can recover from it. These tables are accessed only via data dictionary APIs. That means you cannot misuse the data dictionary. Like in the case of FRM, there were many hacks. I will discuss some of them in the later slides. And the information schema. Now the information schema will be converted to views. That means they will directly file select queries on the data dictionary tables instead of performing file and table scans every time. So this gives us optimized and improved performance in case of information schema. And there is metadata versioning. Metadata versioning will be basically used for upgrading and backward compatibility. I will discuss about this more in the later slide. And extendable. This basically refers to whenever you add any new database object, you can simply add a column or a table in the data dictionary to extend it. So this is the diagram I referred previously. The whole data dictionary was consisting of the file system, system tables and internal dictionary. Now everything will be replaced by dictionary tables. This is a transition slide in which it shows the transition of the data dictionary. In the next slide shows how the information schema has changed from all this type of scans to simple views on data dictionary tables. And storage engines can interact with data dictionary tables whenever required to store their internal data. So this data dictionary stores whatever was stored in .frm files, the system tables, as well as the storage engines. So the basic design goals of data dictionary was it should be accessible to server core, storage engines, and for plugins. That makes it hard to misuse, and data dictionary provides a way to handle storage engine specific metadata, because the storage engine also needs to store metadata at the same place where server is storing, and storage engine APIs have been given a way to access the data dictionary. I talked about redundancy in data dictionary. So this is how data dictionary provides redundancy. For every table you created, the data dictionary creates a .sdi file, which is serialized dictionary information. This is a file, user readable in JSON format. For InnoDB, these files are stored inside table spaces. For other engines, it is stored in normal files. So all information in the data dictionary is present here also. In case of a server crash, these files can be imported in the server and your tables are ready to use again. Further, there was a very good way in which people used to migrate the MySQL tables. They could just copy .myd, which they could just copy the MYD file, which is the data file, and index file, and .frm file, and move to a new server, and their table, the new server will recognize their tables, and they can perform queries on that. So with the introduction of a central data dictionary, this feature, moving around with the copying, is difficult. So the SDI files provide a way to export the data dictionary information in .sdi files, and you can copy all these three files to a new server and do an import on new server, and your table will be ready to used again. And this provides, and in case of InnoDB, you can just copy your table spaces to other server, do an import on table space, and your InnoDB tables will be migrated to a new server. Bootstrapping, chicken or the egg problem. So I hear this question many times. So if the data dictionary tables are InnoDB tables, how do you open them first time? Where is the metadata for the data dictionary tables are stored? So these tables structures are hard coded into the server code. So whenever these tables are accessed at first time for the bootstrapping, the server reads the hard coded values, creates the structure needed to open the dictionary tables, then it opens the dictionary tables and it caches them permanently. So data dictionary tables, whenever you perform any query on any table, it goes to fetch the metadata of that table, it goes to data dictionary and it performs the read of the dictionary tables to get the metadata. So this making persistent structures in cache leads to a huge improvement in performance. Now let's say in future you added a new table to your dictionary tables, or the structure of a column is changed, but your data directory has old data dictionary tables. How the upgrades will be performed? How your new binary will recognize that I am working on an old data dictionary? So for that we have added a version number or the versioning of metadata. One table is added in the data directory with only one row and one column which will contain the version number of the dictionary. This will be used for backward compatibility and upgrade. Now let us move to the benefits of data dictionary. So this is a query which gives the total length of the tables per schema per engine. So this in the benchmarking in 5.7.5 this query used to take 0.38 seconds, and we have done a labs release of data dictionary which is available at labs.mysql.com. The performance of this query can be seen hugely improved. So the performance of information schema will be improved hugely, as now they are not doing any type of scans except they are the views on the data dictionary itself. In case of server crash, so whenever the server crashes and your FRM files are corrupted, there is a chance that you might lose your data, or if your backup is not updated, your FRM file is lost, then how to recover those data? So in previous day there were some hacks available, but you need to know the structure of the table beforehand to use any of those hacks. With the data dictionary, the dictionary information is redundant, that means stored more than once. So you can just import the SDI files and you can start working. So the metadata becomes crash safe. For plugin developers, so there were no defined way to store for other developers how to extend information schema, performance schema, and how to store their metadata. Now data dictionary provides a way for the plugin developers to create their own tables in the dictionary and extend information and performance schema on them. So in a nutshell, this is the traditional MySQL dictionary and this is the new data dictionary. Now we are with the new data dictionary, MySQL is crash safe. Inside InnoDB tables, this is a single repository of data. The information schema are converted to views. It is designed to be extendable. It aims for backward compatibility, means all your old data files and everything will keep working even with the new data dictionary. And there has been a huge amount of re-engineering and restructuring in the server with this data dictionary. Thank you. Any questions?
What if there's an upgrade?
So,
let's say from 5.6 to this will be the 5.7, the new features.
So whenever the data dictionary comes, the server will provide a way to update, which will read all your content from the .frm files, the InnoDB internal dictionaries, and the MySQL system tables to put the metadata into data dictionary.
So whenever there's an upgrade, let's say if we do an RPM upgrade, we don't need to do anything on the MySQL side. We don't need to perform something like an upgrade.
You will need to start the server in the upgrade mode first, which will upgrade the everything. And then how currently upgrade works is you install the new binaries, run the MySQL upgrade client tool, which updates the system tables. So for this data dictionary, you will need to start the server in upgrade mode, which will do the migration of the data from FRM files to dictionary tables. Then run the MySQL client tool, which will upgrade the system tables itself, and then you can start working.
Just as well on InnoDB and ISM, or must it work on InnoDB?
So the dictionary tables itself are InnoDB tables. So MySQL is not initialized when the dictionary is initialized. When the server starts, MySQL will keep working as it was working. There is nothing changed in this. Any more questions? Thank you.